Okay, so in this particular video, what you'll be seeing is self-induction of a long solenoid. See, for a solenoid, last chapter you guys learned that the magnetic field from a solenoid is given by mu naught Ni, correct? So we have B is equal to mu naught Ni. Now we are trying to find the self-induction of this long solenoid. Now for this, what we'll do is, so we'll have to consider the flux which is going through the loops in particular solenoid. All right. So now see, you have, look at this solenoid. So we have the length to be L and the area of cross section to be A. Okay. Now what we are considering is it's a very long solenoid, meaning the length is very big compared to that of the radius. Okay. Fine. So you have one singleton. So consider one loop. See, for this one loop, let's say the area is A. Then we have the flux to be B into A. Correct? So that's basically phi. So phi is equal to B into A. So B is equal to mu naught Ni. So we have phi is equal to mu naught Ni into A. Correct? Now see, this is the flux for one loop. So we have n number of loops like that. So that means the total flux will be the magnetic field which is passing through each loop. Correct? So each loop into total number of turns. Right. So now what we have, see, we have the magnetic flux through one loop is given by mu naught Nia, correct? And the total number of turns. See, there are the total length is L, and if there are n number of turns per unit length, then total number of turns will be n into L. So we come across this equation, phi is equal to mu naught Nia into n into L. Okay, so this will be the total flux. Okay, now what was the magnetic flux of any particular coil by self-induction? So we just figured it out, which was phi is equal to L into I. Right, so equate these two. So we have phi is equal to L into I, which is also equal to mu naught Nia into n into L. Okay, so I and I will get cancelled. So finally you end up with L is equal to mu naught n square A into L. Okay, now this particular formula is the self-induction of a very long solenoid. Alright, so I'll just go through the derivation again. So what you have is, you have a solenoid, a coil, and then the length is very long compared to that of the radius. Okay, so what we are doing is, we are trying to figure out the flux for one coil, I mean the one loop, and then we just multiply the same thing for n number of loops. Alright, so you get this as mu naught Nia into n into L, which is also equal to L into I. Okay, the self-induction of a coil. So I and I will get cancelled. So you just get L is equal to mu naught n square A into L. Alright, so this is the self-inductance of a long solenoid. Now coming to the SI unit is Henry. Okay, now in the next video you will see what if we have two solenoids, then what will be the mutual induction.